National Electrical Code Section 645.10 addresses disconnecting means for information technology equipment, and it requires a readily accessible emergency power off switch or push button. Let's explore the interpretation of this code section for emergency power off systems, often called EPO systems, in facilities that have two utility services. The answer is yes. An emergency power off system can indeed be installed that is separated into what is called an A system and a B system in a facility with two utility services. This configuration is permitted because it aligns with the intent of National Electrical Code Section 645.10, which is to offer a way to quickly and safely disconnect power to information technology equipment during an emergency. There are specific requirements to consider. Firstly, each emergency power-off system, both the A and the B systems, must have the capability to disconnect power to all information technology equipment within its designated area. Secondly, it is important that the information technology equipment is dual-corded. This ensures that all equipment is fully powered down when either the A or the B emergency power-off system is activated. Thirdly, the emergency power-off push buttons must be prominently displayed and readily accessible within the technology equipment room. Let's now discuss some of the advantages of this configuration. Firstly, improved safety is achieved by enabling the isolation of power to specific areas of the facility during an emergency situation. Secondly, it offers maintenance flexibility. Servicing one emergency power-off system can be done without disrupting the operation of the other system. Thirdly, enhanced reliability is provided through redundancy, meaning that in the event of a failure in one emergency power-off system, the other system is available as a backup. There are additional considerations to keep in mind. Firstly, the emergency power-off system should be clearly labeled and indicated on the electrical drawings. This facilitates easy identification in case of an emergency or during maintenance. Secondly, the facility should maintain a written emergency response plan. This plan should include detailed procedures for operating the emergency power-off systems. Thirdly, the emergency power-off systems should undergo regular inspections and testing. This ensures that they are functioning correctly and ready for use when needed. By adhering to these requirements and considerations, an emergency power-off system can be safely and effectively installed in a facility that uses two utility services. This installation provides a reliable means of disconnecting power to information technology equipment in the event of an emergency. The aim is to provide a clear understanding of National Electrical Code Section 645.10 in the context of facilities with dual utility services and to provide guidance on the proper implementation of emergency power-off systems. Consider a scenario where a data center has critical servers and network devices that require an uninterrupted power supply. To achieve this, the data center is equipped with two separate utility feeds, designated as A and B. Each utility feed powers half of the equipment in the data center. This redundancy ensures that if one utility feed fails, the other can continue to power the critical equipment. To enhance safety, the data center implements an emergency power-off system, which is also divided into A and B systems. The emergency power-off system is designed to disconnect power to the utility feed, while the B emergency power-off system disconnects power to the B utility feed. Each emergency power-off system controls half of the heating, ventilation, and air conditioning equipment and half of the power distribution units in the technology equipment room. This setup ensures that in an emergency, either emergency power-off system can shut down its respective utility feed and associated equipment, preventing further damage or hazards. The information technology equipment in the data center is dual-corded, meaning that each device has two power cords, one connected to the A utility feed and the other to the B utility feed. This dual-corded configuration ensures that if one utility feed is disconnected, the device will continue to operate on the other feed, maintaining uptime. However, in a true emergency, both emergency power-off systems can be activated to completely shut down all power to the information technology equipment, preventing any potential risks. The emergency power-off push buttons are strategically placed throughout the data center, clearly labeled and easily accessible to personnel. Regular inspections and testing of the emergency power-off systems are conducted to verify their proper operation. The data center also maintains a comprehensive emergency response plan that outlines the procedures for using the emergency power-off systems and other safety measures. The emergency power-off system disconnects power to half of the heating, ventilation, and air conditioning equipment, ensuring that the cooling and ventilation systems are partially shut down to prevent overheating or other issues. Similarly, the emergency power-off system disconnects power to half of the power distribution units, which supply power to the information technology equipment. This ensures that the devices connected to those power distribution units are safely powered down. The B emergency power-off system mirrors the functionality of the emergency power-off system, disconnecting power to the other half of the heating, ventilation, and air conditioning equipment and power distribution units. This ensures that all critical systems can be shut down in an emergency, regardless of which emergency power-off system is activated. The dual-corded information technology equipment is a critical component of the setup. Each device has two power cords, one connected to the utility feed and the other to the B utility feed. This redundancy ensures that if one utility feed is lost, the device will continue to operate on the other feed, minimizing downtime. However, in an emergency, both emergency power-off systems can be activated to completely shut down all power to the information technology equipment. This prevents any potential risks, such as electrical fires or equipment damage. The placement of the emergency power-off push buttons is carefully considered. They are located in easily accessible areas, such as near exit doors and in the main control room. The push buttons are clearly labeled with instructions on how to activate them. Regular inspections and testing of the emergency power-off systems are essential to ensure their proper operation. These tests involve simulating emergency scenarios and verifying that the emergency power-off systems correctly disconnect power to the designated equipment. The data center's emergency response plan outlines the procedures for using the emergency power-off systems and other safety measures. This plan is regularly reviewed and updated to reflect any changes in the facility or equipment. Consider a specific example where a fire breaks out in the data center. Upon discovering the fire, personnel immediately activate both the A and B emergency power-off systems. The emergency power-off system disconnects power to the utility feed, half of the heating, ventilation, and air conditioning equipment, and half of the power distribution units. The B emergency power-off system disconnects power to the B utility feed, the other half of the heating, ventilation, and air conditioning equipment, and the other half of the power distribution units. All of the dual-corded information technology equipment is now completely powered down, minimizing the risk of electrical hazards and preventing further damage. The fire suppression system is activated, and emergency responders arrive to extinguish the fire. Once the fire is extinguished and the facility is deemed safe, the emergency power-off systems are reset, and power is gradually restored to the information technology equipment. The data center's emergency response team assesses the damage and begins the process of recovering any lost data or services. This example illustrates the importance of having a well-designed and properly maintained emergency power-off system in a data center with dual utility services. The emergency power-off system provides a critical safety measure that can prevent further damage and protect personnel in the event of an emergency. Facilities with dual utility services require a comprehensive approach to electrical safety, and the emergency power-off system is a key component of this approach. It is essential to follow the requirements of National Electrical Code Section 645.10 and other relevant codes and standards to ensure that the emergency power-off system is properly installed and maintained. Regular inspections and testing are crucial to verify that the emergency power-off system is functioning correctly. The emergency response plan should be regularly reviewed and updated to reflect any changes in the facility or equipment. By taking these steps, facilities with dual utility services can minimize the risk of electrical hazards and protect personnel and equipment in the event of an emergency. In summary, the ability to separate the emergency power-off system into A and B systems in a facility with dual utility services is a permitted and effective approach. It enhances safety, provides maintenance flexibility, and ensures reliability through redundancy. However, it is crucial to adhere to the specific requirements outlined in National Electrical Code Section 645.10 and other relevant codes and standards to ensure that the emergency power-off system is properly designed, installed, and maintained. This includes ensuring that each emergency power-off system can disconnect power to all information technology equipment within its designated area, that the information technology equipment is dual-corded, and that the emergency power-off push buttons are prominently displayed and readily accessible. Regular inspections and testing of the emergency power-off systems are essential to verify their proper operation. The facility's emergency response plan should outline the procedures for using the emergency power-off systems and other safety measures. The emergency response plan should be regularly reviewed and updated to reflect any changes in the facility or equipment. By following these guidelines, facilities with dual utility services can create a safe and reliable environment for their information technology equipment. The emergency power-off system serves as a critical safety measure that can prevent further damage and protect personnel in the event of an emergency. This proactive approach to electrical safety is essential for maintaining business continuity and minimizing the impact of unexpected events. Let's consider some additional scenarios where an emergency power-off system might be needed. In addition to fires, other emergencies that could necessitate the use of an emergency power-off system include floods, earthquakes, and power outages. In the event of a flood, the emergency power-off system can be used to disconnect power to equipment that is at risk of being submerged. This can prevent electrical shocks and further damage to the equipment. In the event of an earthquake, the emergency power-off system can be used to disconnect power to equipment that may have been damaged or dislodged. This can prevent electrical fires and other hazards. In the event of a power outage, the emergency power-off system can be used to safely shut down equipment and prevent data loss or corruption. This can also help to prevent damage to equipment caused by power surges when power is restored. The emergency power-off system is a versatile safety tool that can be used in a variety of emergency situations. It is important to have a well-designed and properly maintained emergency power-off system in place to protect personnel and equipment. The emergency power-off system is just one component of a comprehensive electrical safety program. Other important components of an electrical safety program include regular electrical inspections, proper grounding and bonding, and the use of personal protective equipment. By implementing a comprehensive electrical safety program, facilities can minimize the risk of electrical hazards and create a safe working environment for their employees. In conclusion, the emergency power-off system is a critical safety measure that can protect personnel and equipment in the event of an emergency. Facilities with dual utility services should carefully consider the requirements of National Electrical Code Section 645.10 and other relevant codes and standards when designing and installing their emergency power-off systems. Regular inspections and testing of the emergency power-off systems are essential to verify their proper operation. The facility's emergency response plan should outline the procedures for using the emergency power-off systems and other safety measures. By taking these steps, facilities can minimize the risk of electrical hazards and create a safe and reliable environment for their operations.